All right, so take a smaller thing here. Waves undergo. Waves undergo. Waves undergo each of the following. Waves undergo each of the following. Number one is reflection. Anybody remember the four things that waves undergo? Reflection. What's the next one? Refraction. What's the next thing? Diffraction, nice. And last thing is, what's the last one? Interference. All right, so waves undergo all four. What we're going to take a look at, we're going to take a brief look at each one of them before we go in depth into all, right? So we're going to take a brief look into each one of them. Yeah, we'll take a while. We'll be real about it. Sorry. Right, so head up reflection, refraction, diffraction, interference, and we'll do. You probably can't do it in the middle page, so you'll do one each, right? Right. So what is reflection? So let's take a look at how we set up, right? Let's say I gave you something nice and smooth like a mirror line. Let's say I gave you something like a mirror. Right? What you have incident on this mirror is a ray. This ray of light, we call this ray of light the incident ray. That's it. Where this incident ray hits the surface, 90 degrees to the surface, we call that point the normal. All right? So here's how reflection works. Right? When you all look at the mirror, what you all observe? A nice smooth mirror. What you all observe? An identical image, right? You observe something identical that's the same distance away, right? That you are from the mirror. And the reason for that is this simple phenomenon here, right? What you have is an incident ray, and when the ray hits the mirror, it's reflected. This is called a reflected ray. Right? And take what you observe. What you are observing is the angle of incidence. That's between the normal and the ray. That angle is the same on both sides. So the angle of incidence is equal to the angle of reflection. Right? So the angle of incidence is equal to the angle of reflection. Right? That is the phenomena of reflection. Okay? Rays enter and leave at the same angle. Right? So you can imagine this as being you and this as being your image. It will be the same distance away from the object. Same size, same everything. All right? You can note that. Take a small note. Draw a diagram first. Head up reflection. Draw a diagram. I'll worry about it. A small thing, a reflection of a wave. The reflection of a wave is a process by which this one. I never seen the notes. I know what it is. Reflection of a wave is a process by which a wave bounces back after hitting a surface or boundary. After hitting a surface or boundary, it cannot. After hitting a surface or boundary, it cannot pass through. Note that during reflection, the wave stays in the original medium. Note that during reflection, the wave stays in the original medium. So if here's air and the wave comes from air, it stays in air. Okay? It doesn't change medium, right? It stays in the original medium. All right. Second thing to note is the normal, right? I want you to be able to draw a normal regardless of where the incident is, right? So write this down. The normal is an imaginary line. The normal is an imaginary line at the normal is an imaginary line at the point of incidence. The normal is an imaginary line at the point of incidence and 90 degrees and 90 degrees to the surface and 90 degrees to the surface. All right. So here we have two small examples. I want us to try and draw the normal for each one. Right? Point of incidence is right here. When the incident rate touches the material, that's the point of incidence. And it's an imaginary line, 90 degrees. Right? I want somebody come on the board, I'll pick somebody. Come on the board and draw the normal. Draw those diagrams in a book and draw the normal for each one of these, draw the normal based on the definition I gave you. I will draw the first first, then he'll choose somebody first. Wait.
Yeah, it fits. It don't have the shape line. Yeah.
Try a normal. Try it, right? Try and draw a normal, right? It should be 90 degrees to the surface. So put that on 90 degree angle as well. All right. Right down both sides. But not correct. But look at both sides. So pick somebody else. Going back and forth, we do number one. Same one, correct. Get some rock. Another record. No, see. Right? Correct. And pick somebody to the next one. Anybody here? Anybody here? Just use the marker now. I will do the water cup.
It working. I get my phone take away. Boom.
Correct.
Right.
Right? That can work. So at the point of incidence, 90 degrees to the surface, right? That's point number one. Note that the number two, to measure the angle. Number two, to measure the angle. This is note that number two. Note that number 1 was to explain what the normal is. This is note that number 2. To measure the angle, we always measure between the ray and the normal. We always measure between the ray and the normal. To measure the angle, we always measure between the ray and the normal.
So when you say right between,
The ray and the normal. Between the ray and the normal. Right? So right here. So between the ray and the normal, that's the angle. Between your ray and the normal, that's the angle. Right? Not between here and here. Not between the surface and the ray. You always measure between the normal and the ray. That's okay? And last thing, the laws of reflection, last thing, the laws of reflection, online, you'll get through. Ethan, how to get through? Justin, how to get through, right? Alright. Last thing, the laws of reflection states that, number 1, the laws of reflection states that number 1, the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. The laws of reflection says that the angle of incidence is equal to the angle of reflection. And the last law, what you say? What's the last law, right? Imagine this is your material here, right? And this singular page is a plane, right? So it's like a plane. So like what we have around us is an infinite number of planes. Okay, so let's pretend this is one plane. So if along this plane, right? Let's say this is the plane. Along the plane, careful, good. Along this plane, right? You have everything happening. You have the incident ray here, you have your normal along this plane, imaginary plane, this thick, right? You have your incident ray, your normal, and the reflected ray all happening along this plane, right? So there is nothing happening here and on the next plane, happening all on one plane. Okay? So the law number 2. Law number 2 states that the normal, the incident ray, the normal, comma, the incident ray, the normal, the incident ray, and the reflected ray all lie on the same plane. All lie on the same plane. Incident ray, the reflected ray, and the normal all lie on the same plane. All right? Right? Most important thing, if you have to remember Newton, written Newton's first law. Reflection, remember I equal to R. Okay? Remember how to draw your normal, remember how to find your angle. Okay? If here is 20, something underwent reflection, here is also 20. All right? Next one, a little bit different, is refraction. Next one is refraction. This is one that we're gonna spend a lot of time on next week. Right. So if you look here, if we have an incident ray, here is the point of incidence. Here is your normal. What would normally happen? Based on reflection, the ray would have come up here, right? Yeah. Just in refraction, what does happen? Right. So instead of the ray going in a straight line and passing through here, what does happen is that the ray undergoes something called refraction, where it slows down in the denser medium, right? Water is more dense than air. So because water is more dense, the ray itself begins to slow down and come towards the normal. So this angle R here is smaller. I is much bigger than R. Okay? And the reason this happens is that the ray slows down. So in refraction, there's a bending of light as it goes from one medium to the next. That's okay? Of course, they must have different densities, right? Yeah. I is called the incident ray. R is called the refracted ray. So I stick a phone in again. Put it away on the down low. Right, most of your past papers, most of your questions have to do with this here. So we spent all our time on this next week. Right, you know, refraction. Refraction is the bending of light. Wait, refraction is the bending of light. Refraction is the bending of light as it travels through mediums. As it travels through mediums. As it travels through mediums of different densities. As it travels through mediums of different densities. As it travels through mediums of different density. What's up? The more dense the medium is. The more dense the medium is. The more dense the medium. The more dense the medium, the more it will undergo refraction. The more dense the medium, the more it will undergo refraction. The more dense the medium, the more it will undergo refraction. Since the wave slows down in denser mediums. Since the wave slows down in denser mediums. Just do the English. First up, how much a ray is refracted? How much a ray is refracted?
Good.
How much? No, same note. How much a ray is refracted is given by the refractive index. It's given by the refractive index. Right? Refractive index, huh? That was in 22. Refractive index is sine I over sine R. So this little value here tells you it's symbol n, right? It tells you how much refraction will happen here. Okay? It tells you how much refraction will happen. All right, we're not going any further into this. I'll give you more on this next week when we focus on this, right? Next one, diffraction. Right. What will happen here, Olya? Here we have a wave. And the wave is about to pass through an opening. So these are little walls, right? And there's an opening. What do you think will happen to the ends of the wave? Can it pass through easily? No. So what happens is the waves kind of spread out a little bit. That is called diffraction, spreading out of a wave. And if the opening even smaller, what will happen? So imagine this wave trying to go through here, it will curve even more, right? So it will spread out even more. Right? Same wavelength earlier. Try to make sure the wavelength being the same. Other. Papa? Yeah. No, you're getting wrong into two papa. Because all the wavelengths be the same. All the spacings be the same, right? Make sure they all have the same wavelength, right?
And they used to be like, I see they used to be napping. Yeah. That is very cute.
Right, can again, diffraction. Diffraction. This one, diffraction. Diffraction is the spreading of a wave. Diffraction is the spreading of a wave. Diffraction. As it passes through, the spreading of a wave as it passes through an opening of width, an opening of width, an opening of width, width. That is, yeah, of width, that is comparable to its wavelength. That is comparable to its wavelength. that is comparable to its wavelength. Right? All that means is this, right? All it means is this. If the opening is large when compared to the wavelength, it won't spread out as much. If the opening is small when compared to the wavelength, it will spread out more. That's all. So the smaller the opening, the greater the spreading. Right, Akira? Yeah? Last one, interference. Chris, sorry, not Chris. So Mary, you remember what in phase and out of phase mean? What does in phase mean? Remember? Richard? Tasha? Huh? Taisha, do you remember what in phase mean? While you're walking along Sam, remember what that class now? Have your come Yeah, in phase mean. All right, so thank you, man. That's 2 points to like that. Right. Right, so in fields are represented like this, right? If two waves are in fields, you might have a crest of that wave meeting a next crest of that wave, or a trough of that wave meeting a trough of that wave. Like Hishesh, whenever this happens, Hishesh, when a crest meets a crest, they're going to get a bigger crest. Right? That is called interference. This is called constructive interference. When a trough meets a trough, you get something twice as large. Right? This is called, whenever they're in fields, this is called constructive interference. Whenever they are out of fields, Vishesh, what do you think will happen here? Huh? I will get smaller, but be exact. What will happen when I press meet a trough? A straight line. Okay? This is called constructive interference. Write that in for me now. I have no more space. Next to this, write constructive interference. Next to this, constructive interference. Right? Remember, this is a trough. And remember, this is a crest. Right. I didn't say Oh, yeah. Right, next to this, right, constructive interference. Next to this, right, destructive interference, right? Right, so we have constructive and destructive.
No, I don't like that. So.
Destructive interference. Right, the wave that destroyed here. Interference occurs. Interference occurs when two or more waves overlap. Interference occurs when two or more waves overlap. So some interference can be constructive when two or more waves overlap. So some interference can be constructive. Interference can be constructive when the waves are in phase, when the overlapping waves, when the overlapping waves are in phase, when the overlapping waves are in phase, when the overlapping waves are in phase, or destructive, when the overlapping waves are out of phase. When the overlapping waves are out of phase. Right, remember, in phase simply means crest and a crest meeting up, or trough and a trough meeting up. Out of phase means these two meeting up. Right, so imagine if a trough overlaps with a crest. Right? If you were to add up the points, right? Let's pretend here is about 2, and let's say here is about -2. When you add up 2 and -2, what will happen? You'll get 0, right? When you add up, let's say here is 1 and here is -1, what will happen? You'll get 0 again. So when you add up all the points from each wave, they will add up to 0. So you end up with this straight line. That's okay? So whenever the waves overlap, you're adding up the points. Right. I'll just explain it here. Right. So those are the 4 things that waves undergo. All right. One small note underneath this. Last thing. Only waves undergo the following properties. Only waves, like everything. So let's skip all of that. Go forward. Only waves undergo these wave properties. What did I say? Something else. Right? Only waves undergo the following properties: reflection, refraction, diffraction, and interference. Right? Only waves undergo these. First up. Light was believed, L-I-G-H-T, right? Light was believed to only have wave properties. Light was believed to only have wave properties until, anybody know the experiment that changed it up? Oh, young doubles with short. Again, P. Until the photoelectric effect. until the photoelectric effect, where Albert Einstein proposed and proved, where Albert Einstein proposed and proved. Right, photoelectric effect, where Albert Einstein proposed and proved that light can also be viewed as particles called photons. Light can also be viewed as particles called photons. Light was believed to only have wave properties until the photoelectric effect, where Albert Einstein proposed and proved that light can also be viewed as particles called photons. Okay, so now light has two properties: wave properties and particle properties. Right? It's known as the wave particle duality of light. Wave particle duality of light. Have enough time, man. All right, so now plenty notes today, right? Next week we're going to focus only on refraction, and we are going to try to study past papers on refraction, right? So next week is an important class because we're going to do everything on refraction next week. Refraction, critical angle, total internal reflection, and things. All right, we'll stop there for today.